In continuing with today's lesson, we're going to talk about dividing monomials. Now let's go back for a second though. When we were multiplying monomials, what would we do with the exponents? If I had, say, x to the third times x to the fifth, we would add the 3 and the 5 and get x to the 8th power. So when we divide monomials, guess what we're going to be doing with the exponents? That's right, we're going to be subtracting them. That's the reason why in number 1, I get m squared. In number 2, I get 7 squared. In number 3, I get p to the third and n to the third. But what makes that happen? Why is that? Well, think about it this way. M to the 6th means multiplying m 6 times. And m to the 4th 4 times. And if you think about how things cancel out, I have these cancel, these factors cancel, these m's cancel, these m's cancel, and I'm left with the m squared. Same thing is going to happen with 7 to the 5th over 7 to the 3rd. You get 2 7's left over. P to the 5th over p squared. 2 of them cancel. You have 3 left over. N to the 4th over n, and n cancels, and you got 3 left over. So that's how we're going to be working with these quotient of powers. But look at number 4, a little bit different, in that now I have a -2 and a positive 14. Well, think about this. If the y to the 7th and y to the 5th were not there, if you just had your coefficients -2 over 14, what would that reduce to? Right, -1 over 7. Now we're going to take 7 y's and 5 y's and cancel them out. What's y to the 7th over y to the 5th? Well, 7 minus 5 is 2, so we're going to have y squared. So if you wrote it -1y squared, I would accept that, but I would prefer -y squared over 7 would be your final answer. But look at number 5. Now this one's a little bit different in that I have x to the third over x in the denominator. That's going to give me x squared. But if I take 4 minus 6, that gives me y to the -2, and I can't have a negative exponent. So what do I do with that -2? Well, I move it into the denominator and make it positive. Or I could just do this. First of all, if you have a fraction bar in your problem, write down a fraction bar in your answer. I'm going to take x to the third over x, and since I have more of them in the numerator, when I subtract 3 minus 1, I get 2, so I'm going to have an x squared. You put that x squared, that answer, where the larger set of x's were to begin with. So I'm going to have x squared here. I have y to the 6th in the denominator and y to the 4th in the numerator. Always take the higher exponent and subtract the smaller exponent. So 6 minus 4, 2. So I'm going to end up with y squared. Always put that answer where the larger set of variables were in the first place. So I'm going to have over y squared. So suffice it to say that you're always going to take the bigger exponent minus the smaller. Whatever the answer is, you put it where the larger set of variables were in the first place. All right, so let's back up for just a second here. Let's just talk about rules in general about how to solve this type of problem. One thing I need you to note. Let's write this down. There are no plus or minus signs. When that's the case, all we're going to be doing is simplifying. But there's a lot of stuff to consider when you are simplifying these monomials, these single terms. There are no plus or minus signs. Let's take care of business this way. The first thing you're always going to do, and let's write this down, number 1, always simplify anything that's in a set of parentheses. Sound familiar? Kind of like order of operations, isn't it? Always simplify whatever's inside parentheses. Number 2. If you have some parentheses raised to some exponent, multiply the exponents to get rid of the parentheses. Step number 3. Move any term that has a negative exponent. Number 4, evaluate your coefficients. And number 5, simplify your variables. And the proper way to do this would be alphabetically, but I'm not going to be that picky. If you were to follow these 5 steps on any one of these problems, I guarantee you'll come up with the right answer. Now keep in mind, note there are what? No plus or minus signs. These are all single terms, and what we're going to do is simplify them using these 5 steps. So let's look at number 1 down here at the bottom. I have x to the third over y squared inside these parentheses. Can that in itself be simplified? We're simplifying anything that's in a set of parentheses. Can x to the third over y squared be simplified? No. Step number 2. If I have an exponent outside the parentheses, multiply the exponents. Let's get rid of those parentheses. I do have this exponent outside the parentheses. I'm going to take it times 3, so I'm going to have x to the 12th. It's going to be over y to the 8th. We're done. Look at number 2. Oh, and by the way, if your problem starts with a fraction bar, you start with a fraction bar. So I've got a fraction bar here in number 2, right? Write down a fraction bar. Here's the reason why. You're going to have stuff that goes in the numerator. You're going to have stuff that goes in the denominator. You may as well start putting things where they belong. Like, for example, in number 2, look at what's inside the parentheses. This can be simplified. How do we do that? Well, we take the 2 and write it down. Nothing's going to simplify with the 2. But look at that v to the 5th over v to the 4th. 5 minus 4 is 1, so I'm going to have v to the 1st in the numerator. I have w to the 3rd and w to the 5th. I'm going to take 5 minus 3 is 2. So I'm going to have w squared, but where do they go? Right, in the denominator, because that's where my larger set of w's were to begin with. Now, all of that is raised to the what power? This third power here. So now I have this term inside the parentheses raised to an exponent. That's where I am here in number 2. If I have an exponent outside the parentheses, I multiply the exponents. Now, the exponent for 2 is 1. So I'm going to take this 1 times 3. I'm going to end up with 2 to the 3rd power. I'm going to have v, it's raised to the first power, so 3 times 1 is 3, so v to the third, over w to the sixth. That 2 to the third I get to evaluate. I get 8 v to the third over w to the sixth. Look at number 3. Well, there's a fraction bar, so that's the first thing I'm writing down. And I'll notice that inside, I can simplify some things here. Not the 3 over the 2, but I can take x to the 6th over x to the 5th and get x. And y to the third over y is y squared. All of that is raised to the 4th power. That means, now, don't take 3 times 4. You do not get 12 here. It's 3 to the 4th power is 81. You have x to the 4th, y to the 8th over, now it's not 2 times 4 is 8. It's 2 to the 4th power is 16. And that is your final answer. Number 4. I believe there's a fraction bar. Start with that. Now the 2 over the 3 doesn't reduce. And the a to the third doesn't reduce. But I do have b to the 5th over b squared. I get b to the third. And all of that is raised to the 3rd power. It's not 2 times 3 is 6. It's 2 to the 3rd power is 8. A to the 3rd, multiply the exponents, a to the 9th. B to the 3rd raised to the 3rd, 3 times 3 is 9, b to the 9th, over 3 to the 3rd, 27. And there's your final answer for number 4. Next page. Number 1. Well, I definitely don't have any parentheses, and I don't have any exponents outside of parentheses, but I do have a negative exponent that needs to be moved. That m to the negative 4 goes into the numerator. So I'm going to have my original m, and then it's going to be times m to the positive 4 power. What goes in the denominator? 1. Don't write m anything over 1, please. You get m to the 5th power as your final answer. In number 2, this p to the negative 8 has to get switched. Anything that has a negative exponent, you have to move it. If it's in the numerator, we're going to put it in the denominator, and I believe that gives us a fraction bar. Now, in the denominator, I already had p to the 3rd. This p to the negative 8 is going to come into the denominator, make p to the positive 8. What's left over in the numerator? I do need my 1 there. Final answer, 1 over p to the 11th. In number 3, 2 to the negative 3 power, I have a negative exponent that needs to move up. So I'm going to have 2 squared. You don't move the 2 squared. It's already a positive exponent. You're taking it times 2 to the 3rd power, which is 2 to the 5th, because you add the exponents, right? 32. Look at number 4. See if this doesn't make sense. This x to the negative 4 moves down because it has a negative exponent. The x to the negative 5 has to move up because it has a negative exponent. Where's your fraction bar? Right there. So the x to the negative 4 goes into the denominator, makes it positive 4. The x to the negative 5 moves into the numerator, makes it x to the positive 5. Now we're going to subtract the exponents and just simply get x as your final answer. See if this one makes sense. And now, how did that happen? Well, I had a fraction raised to a negative exponent. And because everything inside the parentheses gets raised to the negative exponent, we know the 3 is going to have to move up. The 2 is going to have to move down. So I basically just flipped it over and made the exponent positive. 3 over 2, quantity squared, 9 over 4. number 1. What's the first thing you're going to do in number 1? Well, if it's not a fraction bar, you're probably off on the wrong foot. So let's make a fraction bar. I don't have any parentheses to eliminate, but I do have some negative exponents. Now, I'm not going to do any simplifying yet. I just want to place all the numbers, all the terms where they belong, top or bottom. The 4 goes on top and the 16 stays on the bottom. Notice I didn't reduce yet. All I'm going to do is place everything where they belong. Now I'm going to go through alphabetically. This c to the negative 5. And notice how I'm crossing them out as I go along so that I know what I've used up and I know what I have to do yet. So the c to the negative 5 moves into the numerator and becomes c to the positive 5. Alphabetical order. This m to the second power stays in the denominator because it's already positive 2. This m to the negative 3 goes into the denominator and makes it positive 3. This n to the 6th stays. This n to the 6th stays. Now I have all positive exponents. Now I can reduce this. Simplify it, whatever you want to call it. Take care of your coefficients first. Reduce the fraction 4 over 16. If all those variables weren't there, what would you do with 4/16? Right, reduce it to 1/4. Is there anything that joins up with a c to the 5th? No, so I have c to the 5th in the numerator. Remember, we're going in alphabetical order, right? In the denominator, I have m to the 2nd times m to the 3rd, which is, right, m to the 5th. The n to the 6th here cancels this n to the 6th, and this would be your final answer. In number 2, what are you starting with? I would start with a fraction bar. This x to the 4th stays in the numerator. Y to the 0 is 1. X to the negative 2 becomes x to the positive 2 in the numerator. Everything came out of the denominator, which leaves me a denominator of 1, which we don't want to write. What's x to the 4th times x squared? X to the 6th. Look at number 3. Is the parentheses 3xy raised to the negative 4 power? No, it's just the u, isn't it? All right, so I'm going to need a fraction bar. And my point here is that when I take out the parentheses, nothing changes. There's no exponent over the 3xy that changes anything there, so it's just going to be 3xy. Let's see now. The u to the negative 4 becomes u to the positive 4 in the denominator. And this u to the 7th stays u to the 7th in the denominator. X to the negative 1 becomes x to the positive 1 in the numerator. And this y squared stays there. I've only rewritten it so that my exponents are now positive. Fraction bar. 3's in the numerator, keep it there. Alphabetical order. What's u to the 4th times u to the 7th? U to the 11th. What's x times x in the numerator? X squared. Now I have a y over y squared. The exponent here is 1. 2 minus 1 is 1, so I'm going to have y to the 1st power. Where? It's right in the denominator. And there's your final answer. In number 4, eliminate the parentheses. Fraction bar. In the numerator, I'm going to take the 2 times this 2, and I'm going to get m to the 4th. I'm going to have n to the 6th over m to the negative 2, n to the negative 2. Because they are negative exponents, they get moved into the numerator. So fraction bar. M to the negative 2 in the denominator becomes m to the positive 2 in the numerator. Leave the m to the fourth, it's already positive. N to the sixth, leave it alone, it's already positive. But the n to the negative 2 becomes n to the positive 2 when you put it into the numerator. It's all over 1. We don't want that 1 in the denominator. We have m to the sixth, because we add the exponents, right? And n to the eighth. In number 5, fraction bar, I have negative 2 raised to the negative 3 power. Put the negative 2 in parentheses, put the negative 3 outside the parentheses. The x has an exponent of 1. 1 times negative 3 is negative 3, so x to the negative 3 power. 2 times negative 3 is negative 6, so y to the negative 6 power. Leave the denominator alone for right now, 4x to the negative 6, y to the fourth. Why am I leaving the denominator there and not changing anything? I'm only taking out the parentheses in the numerator. Now I get to move negative exponents. What do you need to start with? Write a fraction bar. So negative 2 to the negative 3 becomes negative 2 to the positive 3. The 4 stays there. Alphabetical order, right? X to the negative 6 becomes x to the positive 6 in the numerator. Cross them out as you use them up. Go up here and cross out the x to the negative 3 in the numerator, makes it x to the positive 3 in the denominator. In the denominator, you have y to the fourth. Leave it alone. It doesn't change. And in the denominator, we're going to put a y to the sixth power. Fraction bar. What's negative 2 to the third power? It's negative 8 times 4, negative 32. What's x to the sixth over x to the third? 6 minus 3 is 3, x to the third. What's y to the fourth times y to the sixth? You add the exponents and you get y to the 10th. Most people will take that negative sign and simply move it into the numerator. But I will accept that whoops. If you leave it there in the denominator, that's fine with me. But like I say, most of the time we're going to take any negative signs and move them into the numerator. You get negative x to the third over 32 y to the 10th. If you have any other questions, we'll talk about them in class. And good luck on your assignment. We'll talk to you then.